So very, very brief recap here. Yesterday was, in terms of the math, wasn't any different than what we did on Wednesday. The main difference is we just swapped out y with an f and an x in parentheses, and we called that f of x. Everything on the right-hand side of the equation stayed the same, and it told us numbers to plug in for x. And so we plugged in the number for x wherever x was. We replaced it, substituted it out, and then we just solved on the right-hand side. And the other thing I want to remind you of is that the left-hand side, this would be f of x equals x plus 7. And then we swapped out x with 5 here and here. And so we were solving for f of 5. The left-hand side is not multiplication like you're used to seeing. The left-hand side is just saying, hey, this is a function. And this over here is the y value. You know, this means is equal to the y value. And when you plug in for x, your answer gives you the x and the y at the end of the problem, which is great because if you have to graph it, it gives you the ordered pair on your final line of the problem. So the ordered pair that would go on the graph here would be the point 5, 12. Now we didn't end up graphing it, but it would be pretty simple to graph because we don't have to go back to the beginning to figure out, well, okay, what was x, where's y? You don't even necessarily need to write it as an ordered pair since it's already here. And so there was a little bit of convenience with that. Things got a little bit more challenging though when we got to the second page, where we had two things to substitute in for. We had to substitute in and solve for the value of the f of whatever the function was. And then once we got that number, we had to plug it back into the original problem at the top here. So like on number 11, we figured out f of 4 first using this f function here. So we plugged in 4 for x into this function, and then we solved it and we got -4. And then this is saying, okay, whatever f of 4 is, -4, add 9 to it. So we got that number, -4 for f of 4, and then we added 9 to that, and we got 5. And there were a few other problems that we did that were similar to that one. And then we finished up by saying, all right, we're given the f of x value, the y value. So we're going to swap out that y value. And then, good morning. Let's see, Jordan, you need yesterday's and today's, I think. So let's see, here's the yesterday's. And right now, we're actually just doing a quick recap and we're going to finish up these three to begin today. The assignment from yesterday with the second. All right. So we said, all right, this is what y is equal to, or f of x. And so we replaced the f of x with the -13 as opposed to replacing x with a number. And then we had a little bit of algebra to do. So just a little bit of algebra. And so this was a two-step equation. We subtracted 8 from both sides, and then we divided by -3. And we said, okay, when f of x is -13, that means that x is equal to 7. So this is just equation solving like we did back in Algebra 1A. And I know we spent probably a good solid 3 weeks or so working on equation solving. So hopefully this was a very familiar process. All right, moving on to what we have today. We've got a word problem, and then these ones at the bottom, I think these ones might be the simplest problems on the entire notes from yesterday. So once we get there, I'll talk about that. So number 17, it says anthropologists use the length of certain bones of the human skeleton to estimate the height of the living person. So basically, an anthropologist is somebody who studies ancient civilizations. And so if they're, sometimes they do archaeology work and they dig up bones of people. And if they find certain bones of people who lived a really long time ago, but they don't find the entire skeleton, they're like, all right, here's the bone. In a normal person, this is like a certain, if the bone is this length, then we can approximate the overall height of the person because generally speaking, proportions between different people are pretty similar. And so they can reasonably estimate how tall somebody was based on certain bones that they find, even if they don't find the entire skeleton. So it says one of these bones is the femur. The femur is like the big bone in your leg, your thigh bone essentially is the femur. To estimate the height in centimeters of a female with a femur length of x, so we're talking about centimeters, that's our unit of measurement, a femur length of x, the function h of x equals 61.41 plus 2.32 times x can be used. Find h of 46 and explain its meaning. So first thing, this problem is just like the ones we did yesterday. So it tells you we are using what value for x? What number are we going to plug in for x in this equation? $46, yeah. So the value of x is going to be 46. So we're just going to go ahead and plug in 46 here, and then do the math. So I'm going to solve it off here on the left because then it says to explain its meaning. So we'll do the explanation over here on the right. So we're going to say h of 46. So we're replacing x with 46 equals 61.41 plus 2.32. Yeah, take class. Times 46. So replacing x with 46 here and over here. And then all we have to do is use our calculators to figure it out. So remember, we're not doing anything mathematically on the left-hand side. This is just telling us, all right, our x value is 46. And then the right side, whatever we solve for over here, that's going to be our y value. So we've got, writing this up just a bit so we can see the calculator, 61.41 plus 2.32. And you can even just put this in parentheses because your calculator understands that that means multiplication. And so if you type it in just like that, you will get an answer of 168.13. Because we have units of measurement, though, we need to make sure that we include those in our answer. So h of 46 equals 168.13. What do we put after that? What unit of measurement is being used? Centimeters, yeah, so cm. All right, now we have some interpretation to do. We solved the math. Now we actually have to explain what's going on here. So this problem told us that one of the bones is the femur. To estimate the height in centimeters of a female with a femur length of x, use this function and solve for x equals 46. So what does this mean? Who can tell me? Femur length of x, we said that x is 46. What does that mean? So we figured out the total height. Okay, so that would be here, right? So the height of the person was about 168.13 centimeters. Okay. How was that calculated, though? What information were we provided with that allowed us to figure out the total height? The femur. Okay. How long was the femur in this particular example? Okay. It's in here somewhere. Anybody see it? What was the length of the femur? So the bone that was found had a particular length. What was the length of that bone? $46, yeah. Yeah, so the length of the femur is the value of x. It says a femur length of x, we substituted in 46 for x, which means that the femur had a length of 46 centimeters. So a femur with length 46 centimeters means the person was, we'll say about, because this is not always going to be exact. So these are estimations because they didn't have the entire skeleton. So the person was about how tall in centimeters? What was the total height of the person? So we used x, 46, to figure out the total height. What was the total height? I realize people are writing right now, so I'll give you a second to get that written down and then think about this question real quick. So how tall was this person? Based on a femur length of 46 centimeters, what was the height of the person? Ash? What's that? Yeah. So it was about 168.13 centimeters tall. That's a good question. I think that there are, what is it, 2.56 centimeters per inch. Is that right? Something like that. I think that's the right number. I'm going to double check just to make sure. I think that's our conversion for that. Centimeters per inch. 2.54, sorry, not 2.56. So 2.54, meaning if we multiply, or not multiply, 2.54 centimeters for 1 inch. So if we take 168.13 and we divide that by 2.54, that's a height of 66.19 inches. So then if we divide that by 12, that is 5.5 feet. So it's about 5 feet 6 inches. Yeah. I mean, when we talk about we're talking about humans, because I think like human predecessors have slightly different scientific names. And so if we're talking about people, humans, the height of people has been increasing over time in general, but it's not like a fast increase. You know, height increases over time, happen slowly. Exactly. So that's it for number 17. Let's look at these last two then, 18 and 19. Now this is where we get to just use a graph and find points on a graph. So I think because there's a visual element, it makes it a little bit more straightforward. So on graph 18 here, we've got x and then f of x, which is the same thing as y. And I know that's like super small print. So definitely use your own paper as you're working on this. It says to figure out f of -3. So basically it just says you're taking the number here for x and then you're going up or down to y to figure out the y value. All it's asking you is, what is the y value when x equals this number right here? So we're going to go -3 on the x-axis. So you start in the middle and you count 1, 2, 3 to the left. How far up do you have to go before you get to that curve? If you go 3 to the left, how far up do you have to go to get to the curve? How many spaces up? So 3 to the left, here's -3 on the x-axis. How far up do you go until you get to the curve? Anybody? So 1, 2, 3. We're getting to the graph. How far up? 2. Yeah. So it's just 2 up. So f of -3 equals 2. So x equals -3, y equals 2. Exactly. We're just figuring out the coordinates of the graph for that particular point. Yep. Yeah. So yeah, like this next one here, go to an x coordinate of 1, and then you're going to go up. How far up do you go? So if you go to an x coordinate of +1, So that's to the right one. That's the x-axis. And then how far up do you go to get to the y-coordinate for that? So over 1 and then up how many? Just 2, yeah. So A and B are the same answer. F of -3 is 2, F of 1 is 2. Next one is F of 0. So we're not going left or right at all. We're just going straight up on the y-axis. How far up do you have to do to get how far up do you have to go to get to the curve? 1, 2, 3, 4, 5. So F of 0 equals 5. So that means we have the point -3, 2. We have the point 1, 2, 0, 5. Then if you go over to 2, where is the y value on this one's a little bit more challenging just because the line gets a little bit steeper. So if you go over to 2, it's going to go down. So our value for y is going to be negative. And it's 1, 2, 3. 3 down. So -3. Oh, it just depends on where the curve is. So like if we go over 2, if we go up, we're not going to end up on the curve at all. We have to go. Yeah, you're going the direction that the graph is going. Exactly. You're finding the spot on the graph for how far over you have to go. So on number 19, we're basically finding a point along this curve, right? We're finding the up or down value on this curve here. And so first we're going to go -4 on the x-axis. So left 4, 1, 2, 3, 4. And then to get to the curve, we have to go up from there. How far up do we have to go to get to the curve from -4? How far up are we going from -4 to get to the curve? Yeah, 2. So if we go from the middle, left 4, because that's -4 on the x-axis, to get to the curve, it's up 2 spaces. So f of -4 equals 2, which is the point -4, 2. If we are at 0, we're already on the curve, aren't we? That point there in the middle is already on the curve. So what's the y value? 0, yeah. So 0, 0. That's the origin. All right. F of 2. Somebody tell me that one. What's the y value when x is 2? What's the y value when x equals 2? Close. 2's the right number, but we need something in front of it. -2. Because we're going down from there. So over 2, down 2 would be a -2. Then f of 5. So let's see, 1, 2, 3, 4, 5. Are we going up or down? Down, how many? Just 1, so -1. All right. So that is it for yesterday's notes. And let's see. Man, lots of people gone today. All right. Let's move on. Talking about zeros today. Now, there's actually not a whole lot of math to do today. There's going to be a little bit of algebra going on, and a little bit of looking at graphs going on. So it's going to be a nice segment, a nice segue into what we're doing today, because we just finished with graphs, and today was notes. We are starting with graphs. So today we are talking about zeros of functions. So that first question is, what are zeros? All right. And so there are 2 ways that we can figure out where the zeros of a function are. Let's see, Caden, do you need these? Okay. Let's see. There's 2 ways we can figure out how to figure out where the zeros are. The first way is to use a graph. The second way is to use algebra. So we're going to do those 2 things today. So graphically, the first thing we're going to do today is using a graph to figure out the zeros. Zeros are the points at which the graph crosses or intersects with the x-axis. So on a graph, to find a zero, all you are looking for is where the line crosses the x-axis. And you just give the x value for that. That's it. So we'll get there in just a second. For algebraically, the way we're going to do this is it's the point or points at which f of x equals 0. And I'll show you how to do that when we get to those problems. So two things we're learning today based on a graph and based on algebra. All right. Now there are other things, there are other ways, kind of like we've seen in almost every, or not every part, but like sort of like we've seen when we're talking about values of x and values of y, how we have a bunch of different names for those. You'll also see different names for zeros. So what else are they called? They're also called roots. They are called x-intercepts. And they're also called solutions. So zeros are known as roots, x-intercepts, solutions, and zeros, the original thing that we're looking at. So figuring out the zeros of functions, looking at graphs. That's right here. So all we're doing here is we are looking for the point at which the line crosses the x-axis. Well, here's our x-axis. This right here is the point where that line crosses the x-axis. Yeah. So what is this x value? Just the x value. How far over from the middle is it? Where this line crosses the x-axis. 2. Yeah, x equals 2. It really is that simple. If you know where the x-coordinate is, where the line crosses the x-axis, you can point to it and say it's that one. Or in the case of number 2, you can say it's that one and that one, because on number 2, this line crosses the x-axis in 2 places, here and here. So what's this x value here? How far from the middle is it? How far to the left? Yeah, so on the right side, it's +1. On the left side, it's -2. So the zeros here, there's 2 of them. So we're going to say x equals, and we're going to use our little braces for this one, -2 and 1. Those are the zeros. Wherever it crosses the x-axis, the x value is the x. We'll do one more as a class, and then I'll have you work on 4, 5, and 6 on your own. So we got number 1, x equals 2, because it's 2 from the middle, 2 to the right. Number 2, it crosses the x-axis twice, here and here. 2 to the left, -2, 1 to the right, +1. All right, let's look at number 3. We've got the point where it crosses the x-axis is right here. So what number is that for x? How far over is it? What number do we get? X equals 3. Yeah. From the middle, it's 1, 2, 3 over 3. So x equals 3. And it's on the positives. So x equals positive 3. So based on that, I would like you to work on problem 4, problem 5, and problem 6. And I'll give you, let's just say, a minute and a half. I'm going to be pretty quick with this. So you're just locating the x coordinates of where the lines cross the x-axis. And that's it. What's that? No, you just identify them. That's it. So just say where they're at. So like how far over on the negatives, how far over on the positives. Kind of like what we did with number 2. So you're just saying like the x coordinate here is -2 and the x coordinate here is +1. So yeah, there's no calculations that we have to do. We're just locating on the graph. Okay, let's look at number 4. So we've got a point right here and another point right here. That's where that line crosses the x-axis. So 2 places this time. So we're gonna have 2 answers for x equals. Any volunteers? What do we have for x here? What are our 2 values for x? I know that quite a few people have the answers here. What do we got? Okay, I'm gonna call on somebody. Ash, go ahead. What'd you get? -4, +1. Excellent. So -4 and 1. Nice. Because from the middle of the graph, if we go 1, 2, 3, 4 to the left, that's where it crosses there. And if we go 1 to the right, that's where it crosses there. So those are the 2 answers, -4, +1. Next one, number 5. We've got 2 answers on this one as well. One here and another one over here. So I would like, let's see. Nope, Caden's not here today. It might take me a while to actually get somebody who's here. Juan's not here today. Maria's not here today. No. Staley's here today. All right. Staley, what do you have for number 5? -1 and 5. Nice. So -1 to the left, and then 1, 2, 3, 4, +5 over there. Good. So 2 answers for this one. -1, +5. Before we figure out the answers for number 6, how many answers will there be? Show of fingers. How many answers are there going to be? 3. Nice. because I got one over here, one here, and then another one here. It crosses the x-axis 3 times. And let's see, Ash, randomly enough, your number came up. Do you have answers for number 6? -5, 0, and 3. Excellent. Yeah. So 1, 2, 3, 4, 5 to the left, that's -5. Right in the middle, 0, and then 1, 2, 3 in the positives. So x equals -5, 0, and 3. Nice. So using a graph, I don't know. I feel like this one might be the simplest way to do it, just because you can actually just go left and right on the x-axis, and you're just using a number line basically and saying, okay, how far over? That's where it crosses. How far over? That's where it crosses. Let's go ahead and move on to the second page then. And on this one, we're going to do a little bit of algebra. None of these problems, though, are more than 2 steps. So solving equations, we're not even looking at like multi-step equations. We're looking at most 2 steps. So first of all, it says step 1 and step 2. That's not like the step 1 and step 2 for the algebra solving. That's step 1 and step 2 to like set up the problem and get it going. So step 1, we're going to go 7 through 12, and then we're going to be done. So we're only going to finish, we're only going to go to number 12 because the rest of these says to use a graphing calculator. We don't have graphing calculators, so that's a tool that we don't have, so we're not going to do any of those. So we're just going through number 12. Step 1, set the function equal to 0. So set the function equal to 0. Now, part of my job is to show you what to do. Another part of my job is to show you why we do it. I consider that, like, I take a lot of pride in my work in trying to actually explain why we are doing what we're doing, not just what you're doing. Knowing what to do practically, that's all you really need to know, but knowing why allows you to maybe use that same thing later on and be like, oh, I actually can see this connection and I know why we're doing it. So I'm going to back up to the previous page real quick. And we are just going to take a look here at these graphs again. The only thing we actually solved for is x. But if I were to ask you, what is the y value on graph number 1 when x is 2? What's the y value for this point? How far up or down are we going? We went to the right too, but how far up or down are we going on this one? Are we going up or down on this one? No. What are we actually finding? What's it called? These are called what? Zeros, right? There's a reason why we call these zeros. What is the y coordinate for this point? I know you know it. What's the y coordinate here? What is it? 0. Hey, that's a great guess. If you're going to the right 2 and you're not going up or down at all, then the y coordinate has to be 0. So let's move on to number 2. What's the y coordinate here? Yeah, all at the same time. This should be like a choir here. What is it? 0, right? 0, y coordinate, 0, y coordinate, 0, 0, 0, 0, 0, 0, 0. These are zeros because the y coordinate is 0. So what we're doing here on the next page, we're setting the function equal to 0 because f of x, what did we replace yesterday with f of x? What letter did we replace f of x? Y got replaced by f of x. And on the previous page, we just said that y equals 0 for all those points. So really what we're doing is we're replacing y, because f of x is the same thing as y, with 0. So we're asking ourselves, what is the x coordinate when y is equal to 0? Because that gives us the point on the graph where the line crosses the x-axis, because anytime y equals 0, that is on the x-axis. So the x value that we solve for has to be on the y-axis, because whenever y is 0, or has to be on the x-axis, because whenever y is equal to 0, it is going to be on the x-axis because it's not up or down. It's right in the middle. So instead of f of x equals 4x minus 8, we're going to write 0 equals 4x minus 8. Yeah, go ahead, take a pass. Every single equation here, you are replacing f of x with 0. And in fact, I'm just going to put a little note at the bottom here. Replace f of x with 0. I'm going to put that right down underneath here just because I ran out of room. And then we'll get to step 2 in a second. But replace f of x with 0. That's what it means by set the function equal to 0. You are replacing f of x with 0. And so that's what we're doing with example 1. You, instead of writing f of x equals 4x minus 8, you're going to write 0 equals 4x minus 8. And then step 2, solve for x. Solve for x. That is step 2. And every single one of these 6 problems are going to be 2-step equations. And if you weren't in my Algebra 1A class, I'm not sure if you drew the line through the equal sign or not. If you didn't, the reason why I do that is just because it helps me keep my equal sign in the exact same place all the way down. That way, the left side of the equal sign and the right side of equal sign are always kind of in line with each other, and it's not like the equal sign isn't like shifting around and doing weird things. So I just line it up by putting a line down there. You're welcome to draw the line. You don't have to, but it's kind of a good idea. Ash, what's up? A shape for every number? Yeah. I'd be very interested to see that approach because that actually sounds really interesting to me. So yeah. Yeah. Bring that in sometime. I want to see it. I got you. Well, I don't know that method, so I'm not going to be doing that. But I would like to see it. So solving for x here, we're just going to use our regular equation solving method. So we already have x on this side, so we're just going to move the regular numbers to the left. So we're going to add 8 to both sides. Negative 8 cancels with positive 8. So just a reminder on equation solving here. 0 plus 8 equals 8. And that's going to be equal to 4x. We've got one more thing to do. What do we have to do here to get x by itself? Division. Yep, we're going to divide both sides by 4 because that's the number that's next to x. That's the number multiplying by x. So the 4's cancel out, and x is equal to 8 divided by 4, which is 2. So x equals 2. That's all we have to do on these problems here on the rest of them. So we'll do, let's say, I'll leave 8 for you to do on your own. We'll do 9 together, and then we'll do one of the fraction ones together, and then I'll have you do the other 3. So let's just make this easy. We'll do 7, 9, and 11, and then I'm going to have you do 8, 10, and 12. So number 9 is the next one. And we are going to replace f of x with 0. So we're going to say 0 is equal to, instead of negative x, does anybody know what I'm going to write? I bet L knows. What am I going to write? Negative 1x. Good. Anytime there's just like a negative hanging out with a variable, I usually put a negative 1 with it because it kind of looks like x is by itself and that this might only be a 1-step equation, but this is still a 2-step equation because of the negative. And when you have a negative right by a variable, that's like having a negative 1. So I just want to make sure that we're all kind of aware of that. So solving for x here, what's my first step? What do I do first? Good. Subtract 7 from both sides. And 0 minus 7 is negative 7. So negative 7 equals negative 1x. All right, now putting the negative 1 here makes it a little more obvious. I still have one more thing to do. What has to be done? How do I get x by itself? Divide. Divide by negative 1. So negative 1's cancel out. And negative 7 divided by negative 1 is 7. So for problem number 1, x equals 2. For problem number 2, or not 2, but 7, x equals 2. Number 9, x equals 7. For the next problem, we'll take a look at number 11. This one says f of x equals 1/2 x plus 2. So again, we are going to replace f of x with 0. Every single problem starts off the same. Replace f of x with 0, and that's going to equal 1/2 x plus 2. Now, this is also a two-step equation, just like the first two. What do we have to do first here on number 11? What's our first step? Subtract 2. By the way, just a reminder, when it's just a two-step equation, you're always going to do the addition or subtraction first because order of operations works backwards when you're working on equations because you're undoing what's already been done. So 0 minus 2 is negative 2, and that would be 1/2 times x right there. Now, we saw an example of this yesterday when we finished up our notes yesterday. When you have a fraction that is multiplying by a variable, we can get rid of that fraction in one step. What is that one step? Multiply both sides by the reciprocal of this fraction. Now, reciprocal is just a fancy way of saying flip it over. So if you flip over the fraction, 2/1, and you multiply both sides by 2/1, that will get rid of the fraction on the right-hand side. So if I say times 2/1, the 1's cross cancel and the 2's cross cancel. And then over on the left-hand side, I'm just going to write times 2 instead of times 2/1. Can anybody tell me why? Why am I writing times 2 instead of times 2/1? Because what? There isn't a need to, yeah, because 2/1 is just 2, isn't it? And since this negative 2 doesn't have a denominator, we don't actually have to use the denominator at all. But that only works if you flip it over and you have a 1 for your denominator. For the other fraction ones here, 10 and 12, when you multiply by the reciprocal, you must keep the denominator. You can't just make it go away. You can only get rid of the denominator if the denominator is 1. So keep that in mind. And then 2 times negative 2 is negative 4. So x equals negative 4. All right. You got 3 more problems to work on, 8, 10, and 12. I'm going to give you, let's say, 3.5 minutes. Try to get those 3 problems solved in 3.5 minutes, solve for x, and then we are done with our notes because we don't have the option of using a graphing calculator, so we'll just stop after number 12. So 3.5 minutes, and then we'll check back in. We'll see how you did. And then you'll have the rest of class to work on the assignments or assignments if you need to work on yesterday's as well. So 8, x equals negative 1. 10, x equals 9, and then 12, x equals 10. All right, are there any questions on those last 3 problems? All right. So we are looking at 15 minutes. And good news about this assignment, this one will also be due on Monday along with the one from yesterday, but today's assignment is only one side of the piece of paper, there's nothing on the back, and you only have to do 1 through 12 because 13 through 18 tell you to use a graphing calculator, which that's a tool that we don't have. So you're only working on 1 through 12. So I would say